This video is a demonstration of a small Z80 computer. This is the computer main board, the Z80 processor. This is a 2K ROM that contains a small series of programs to test the system. 1K RAM, support chips. This is a 2 megahertz crystal. These switches control whether the fast or slow clock is working and whether it's in reset or running. It has 2 output ports with these 8 LEDs each, and 2 input ports, which are these 8 little switches on each port. This is a display board that shows the activity of the computer buses. Right now the slow clock is running. You can see it flashing. When the 2 megahertz clock is running, this is just a blur. And it's currently in reset. This is an active low signal, so when the light's off, that means it's in reset. This displays the address that's being put out by the CPU, and this displays what's on the data bus. It's set up to run a program that counts to 1,000,000, and I will let it loose and on the slow clock and start it going. So you can see it's running through addresses on its way to start the program. This is a clock that only runs a few cycles a second, so you can see what is happening in the computer on the buses over here. Eventually, when it starts to run the program, you will begin to see output on the output ports. Once the processor counts a full byte, 256, the light will turn on, and then another 256 cycles, it'll go to binary. This is binary 1, then it'll go to binary 2, and then 3, etc. So every 256 cycles, it will add 1 to the output port. If you watch the bus lights, you can tell when it writes to the output port because you'll have a write signal accompanying a input-output request signal there. And you can see that we have 2 on here now. So it takes 15 seconds or so to count each single unit. Now I'll put it back in reset and I will change the clock to use the 2 megahertz clock. So with the 2 megahertz clock, the clock cycle is just a blur. You can't see it flashing. And when I take it out of reset, you'll see the counting begin again, and you'll see that it's much faster, as it should be 1,000,000 times faster. So I'm 256 times 256, 64,000 counts are made. So at 2 megahertz, you can see it really moves pretty quickly. Oh, that's the demonstration.